Hi everybody, welcome to another video in Math 1332, section 3.7, arguments and the truth tables. Arguments. An argument consists of two parts, the premises, the given statement, and then the conclusion, the result determined by the truth of the premises. And a valid argument is the conclusion is true whenever the premises are assumed to be true. An invalid argument, or called a fallacy, is not valid argument, and we use truth table for that. In particular, we write the arguments in symbols, and then we construct a truth table for it, and we write the conjunction between all the premises and with the implication for the conclusion, and that implication is the same as that, but for the argument we just use the double arrow for the implication, and then we just set up the truth table. If we have true everywhere on the last column, then it's said to be a valid argument. Alright, let's look at the first case. P or Q, not Q, imply Q. Right. Now, so I'm just going to write P or Q is one premise, and down conjunction with not Q. So all the premises conjunction imply. I'll just use double arrow here, Q. Let's see how many do we need. 1, 2, 3, 4. So be 6 with the P or Q recently. That should do it. So P or Q is the usual thing here. True, false, and then true, false. Right, so for this, let's just first do the disjunction of P or Q. And this is true when both of them are true and false everywhere else. And now we're going to do not Q. Not Q. So that is Q. Just not Q will be false, true. Now we do the conjunction. Right. Conjunction is true when both of them are true and everywhere else are false. So what we have here, we don't have anything that both true, so it's going to be all false. And finally, this column was here, so meaning we're going to have that which is the left statement here imply Q. So that column imply Q. Right, so from this implication the other way, right? So we have false implied true is false. False implied false, false. Pretty much, if we start with false, I'm sorry, got them backwards. For the implication, if we start with false, it's always true. So remember, I talk about that example all the time. If I am a Superman, doesn't matter what I say after that is a true statement. Because if I start with something false, it doesn't matter. It is always true. So with that, this is a valid argument because all of them are true. Right? Next we have P or Q, and then we have P, not Q. Right, let's see. If you rewrite this as an argument P or Q conjunction with P imply Q, imply not Q. Right. I'll just fill the column as we need. I'm not sure why the column need to be. Right, P, Q, true, false, true, false, true, true, false, false. Now first we do the disjunction. So it's true when both are true, everywhere else are false. And now we do that conjunction with P. Right, so that conjunction with P. It is true if when both are true. Right, this and that, and false everywhere else. Every different scenario, I should not say everywhere else. It's true when both are true. Every different scenarios false. Right, now we're gonna need that implication to Q. Right. So we're gonna have that imply P. I'm sorry. Imply not Q. We need one column for not Q. Well, just improvise. Yeah, let's just do the not Q over here. Right. This is Q. Not Q. False, true, false, true. Right? So that complement negation of Q. Now, all we need is that implies not Q. So true implies false. This is false. False implies true. That true. That true. And that true. Well, we have the case here that true implies false. So that's why this is not a valid argument. Right. So this is an example of, let's say, P or Q. So the jacket is warm, the jacket is light. If it is light, then it's not warm. So, well, that's not true because they might be still both warm and light. So that's an example to that. Right, next. Now we have, instead of the statement like this, we have a real problem. So in Star Trek, the specific, so some kind of scenarios here. I would say the Captain Cook wonders if Mr. Scott is aware of the problem. And Mr. Spock replies, if Mr. Scott is still with us, the power should be on momentarily. And a moment later, the ship powers come back. So this is the argument we write like this. And therefore, so they are the premises, and that is the conclusion. Right, so I just write out a bunch of letters for that. So if Mr. Scott is still with us, so that is P, the powers will continue, will come on. So we have P implies Q. The power come on, which is Q. And therefore, still with us P. Right, determine if this is a valid argument or not. Well, we'll rewrite this as P imply Q, one premise, and another one imply P. Right, so P, Q, true, false, true, false, true, true, false, false. We have P imply Q, and this is false only if we have a true imply false. So this is false. Every other scenario is going to be true. Yeah, so only that. Now we have that conjunction with Q. It is if both of them are true, then it's true. Every other scenario is false. This we do have both true, and this is false. Right. Now, when we have that, we have that imply Q. We have that imply Q. True implies true is true. False implies anything is true. True implies true is true. And false implies anything is true. Wait, that implies P, right? Never mind. Let's try that again. True implies true. That is true. False implies true. False implies anything is true. True implies false. Now that is false. The last one true. So because of that, this is not a valid argument. Next, I will run for student governor. I will join the athletic boosters. I did not do this, therefore I will run for the student governor. Alright, so let's convert this into a logical statement and then try to prove it. I will run for the president, student government, sorry, P or Q. And I did not join, this will mean not Q. Imply P, right? Because you run for student governor, that P, right? Oh, let's write out the statement we need to prove. So I will write up here P or Q, and not P, not Q, imply P. Right. So true, false, true, false, true, true, false, false. Now the disjunction. It's going to be false when both are false and every other scenarios are true. Right, so we have the first one. Next we need not Q. Fall true, fall true. And now the conjunction of these two. Right, conjunction of both of them. So it's true when both are true. Everywhere, every other scenarios are false. Now we're going to have this imply P. So if that imply P. So false imply anything is true. True imply true is true. False imply anything is false. I'm sorry. False imply anything is true. and false implies anything is true. So this is good. This is a valid argument because all of them are true. Right. Right. So the last column is all true. So this is a valid argument. Right. The next part of the section now gives you some example of the very common argument or the common fallacies. I will let you read it. So, and we just need to do the last one here. Use the given forms of valid arguments and fallacies to decide if each argument is valid. Of course, we compare this to what we have earlier, but I just do this again. Right. If you eat a healthy diet, so that P, then you live past 70, that Q. You really make an effort to eat healthy, so the healthy part is a P, right? And therefore Q. So P implies Q, and we have P, so all that can it give Q, right? So just make a table, proof for it. Of course there are names for it, but it's much better we can just do it and memorize it. P or Q. Alright, the last one will be true false, and then true, false. The very last one I will say P implies Q, and P, so that's not Q, implies Q, sorry. So that's the last column that we need to prove. Right, so first P implies Q. P implies Q, so it only false when true implies false. Every other scenarios are true. Now we're going to do that conjunction with P. Like that, conjunction with P. So true and true is true, false, for true, false, for true, false. Because conjunction is true only when both of them are true. Every other scenarios are false. Now we have that imply Q. So this column imply Q. True implies true. True. False implies anything is false. Is true. Sorry. False implies anything is true. False implies anything is true. Yeah. So just like that. Right. So once again we have this imply Q. So true implies true is true. False implies anything is false. False implies anything is false implies anything is true. False implies anything is true. And false implies anything is true. We go the other way. Back to Q. Right. So and we see we have all true at the end. So this is a valid argument. Yeah. So it's valid. So that is valid argument. So with that, we finish section 3.7. As always, thank you for watching and see you in another video in Math 1332.